pour me 2 glasses and shake them together. That's gross. Unless a vintner's is in the business of blending wines. There's some delicious blends out there. But the point here is, to me, they're imperfect substitutes. I'll take a little bit more Zin, and I'm willing to give up a little bit of Pinot Noir, or I'll take a little bit more Pinot Noir for a little bit less of the Zinfandel. So imperfect substitutes, those are the... So here's the Zin, here's the Pinot Noir. Thank you for auto-saving for me this amazing lecture. Now go away. Afraid of touching this thing now. Okay. This is an indifference curve that we call imperfect substitutes. You're willing to substitute between Zinfandel and Pinot Noir. This is the type of indifference curve that everything started with, right? You're willing to substitute away from Zin. You're willing to give up some Zinfandel for some more Pinot Noir at a diminishing rate, meaning your marginal rate of substitution becomes a smaller and smaller negative number along this indifference curve right here. And if you have a lot of Pinot Noir and little Zinfandel, you're willing to give up a little bit of Zinfandel for one more unit of Pinot Noir. If you're somewhere at the top left where you have a lot of Zinfandel and little Pinot Noir, you might be willing to give up quite a bit of Zinfandel for one more unit of Pinot Noir. So we've got 3 different types of indifference curves. They are imperfect substitutes, and then on the other extreme we have perfect substitutes, and then on the other extreme we have perfect complements, right? If we put them all in one picture, which I don't want to put in the digital version here because then people who weren't paying attention and just woke up from their YouTube screaming, but if we were to draw this in one picture, and indifference curves don't ever cross, so these are the indifference curves for 3 different individuals on the same graph, okay? Good A, good B. The individual that regards these goods as imperfect substitutes, his or her indifference curve would look something like this. The individual that looks at these as perfect complements, their indifference curve would look something like this. And the individual that looks at these as perfect substitutes, their indifference curve would look something like this. Okay, so this is perfect substitutes. This is complements. And this here is imperfect substitutes. Right? And if you rank them, this goes from you're not willing to substitute at all, you're willing to substitute a little bit at a diminishing rate as you go towards Miami, and here you're willing to substitute at a constant rate. The cool thing about this is there's no economist in the world that can tell you what your indifference curves look like, right? Some people have really weird preferences. My closest friend in high school really liked dark bread with liverwurst and honey. Perfect compliments. What you ate for breakfast every day. I don't eat meat, so that whole thing just freaks me out. But people have weird preferences. So whether you like things as certain complements or you regard them as perfect complements, perfect substitutes, or imperfect substitutes, it's up to you, right? You don't really decide it. Maybe you're born the way you feel about certain things. This is beyond my area of expertise. But everybody has different preferences over the same set of goods, and what those are is fully up to you. That's not up to some economic modeler to decide, but that's up to you that we can tease out in an experimental setting what your preferences look like. But it's really nothing that comes out of a model. That's something that comes out of your giant brains, hearts, and souls. All right? All right. Now, the other thing I wanted to point out before we get into a very nice little performance art piece performed by yours truly is when you look at textbooks, and that's why I hate PowerPoint, everything always looks perfect, right? Curves, they never have a squiggly line. They look perfectly parallel, and everything looks just so nice. Indifference curves don't have to be parallel, all right? So in difference curves, it's perfectly fine to see something like this. So think of rice and water, okay? So at low levels of consumption, low levels of consumption, this indifference curve could look almost like a perfect complements one. Then as we consume more, they look something like this, right? Where this is the lowest level of happiness, second highest level of happiness, third highest, fourth. So I5 is highest level of happiness, I1 is lowest level of happiness. Thank you for stealing it again, it'll come back. But the point here is, again, if I drew a straight line from the origin out towards Boston, what you would see is that, the further away you get from the origin on that straight line, the higher your level of happiness gets. Come on back. I have a teachable moment here, Microsoft. There we go. All right, thank you. So what does this indifference curve look like? Ignore the squiggliness for a second. Does that look more like perfect substitutes or perfect complements? Complements, right? What does I5 look like? Imperfect substitutes, but it starts to get more like a perfect substitutes line. So here what we've got is, these are very low levels of consumption. 1 bowl of rice a day and one good big glass of clean water a day, right? At really low levels of consumption, if you're thinking of the poorest of the poor that get by on less than $2 a day, there's a certain minimum caloric requirement that you need every day in terms of how much rice you need to consume and how much water you need to drink to just stay alive. And that constraint is binding on both sides, the food and the liquids dimension. So you regard rice and clean water as perfect complements because you're at a very low level of consumption, right? It's minimum requirements for the ability to survive. As incomes go up a little bit, and we'll talk about what that means more formally, but as you can afford more, let's say 3 units of water and 2 units of rice, your willingness to substitute between these two for this individual goes up a little bit, right? Because you're a little bit beyond this minimum level of calories and water in order to be able to survive. And as you get more of both goods, your willingness to substitute between these two for this particular individual here goes up. So what I'm saying here, these indifference curves don't necessarily need to be draw this curve, hit apple C, and then paste, so you have these parallel indifference curves. But the shape of these indifference curves as we go from the origin out towards the northeast here really tells us something about how an individual regards these two goods over different levels of consumption. And we'll see that as we go out to the northeast here, that generally means being wealthier, but we will formalize this, right? So indifference curves don't have to be parallel, but they can't ever cross, right? We've got to deal on that one. Okay, here comes a little bit of math. Okay, it's not that hard, but it's math that terrifies some people, not everybody. So this notion of actually you like something better, you like bundle A better than bundle B, I would like to formalize this a little bit more, okay? So what I'm going to do is I'm going to assign something, a value, a numerical value, to levels of happiness. Max, and this is where economists drove me crazy in Econ 1. I didn't get that at all, right? We can measure all kinds of things. We can measure Lance Armstrong's time on all 10 Tour de France's that he rode in. We can measure height in this class, from tallest to not so tallest. We can measure probability that you could have beaten Boris Becker when he was 17 at Wimbledon, right? We've got a couple of Cal tennis team people in here. I assume you could have beaten him. I think it was unbeatable at that age, but that's a different story. So the notion is we can measure lots of things, but can we measure happiness? Maybe. What do you think? Can we measure happiness? How'd you do it? Well, it turns out there's a whole field out there that's trying to do this, right? There are people who are taking tweets and doing textual analysis on what people are doing in their tweets and assigning numerical values of emotional states to these tweets and are mapping out states of mind across space based on the flow of tweets coming through the, what's it called? It's not called the Twitter sphere, is it? What, Twitterverse? Whatever it is. I'm not so techie. But the notion is we're going to make it really simple here. I'm going to define something called utility. Utility is a numerical value of happiness. Its units are utils. Anybody here ever heard of utils? Maybe in Econ 1, right? That's the only time you hear it. Non-economists don't talk about utils. Utils are artificial measures of happiness. Utils I'm going to assign to bundles. So if Joe prefers bundle A to bundle B, then the utility, meaning the number of utils Joe gets out of bundle A, are higher than the number of utils Joe gets out of bundle B. Right? So utils reflect one thing only. They reflect the relative ranking for one individual between two bundles. So if one bundle gives you a higher number of utils than the other, that means you prefer that bundle A that gives you the higher number of utils to bundle B that gives you the lower number of utils. It's something that economists came up with in order to put a numerical value on happiness. The actual number of utils itself doesn't mean anything. It's an ordinal thing, and we'll talk about that in a second. It just reflects a ranking. It's not like dollars, where $2 are twice as much as $1. 2 utils aren't necessarily twice the amount of happiness as 1 util. They're just more happiness than the 1 util. They allow you to rank things, but they don't allow you to make a distance comparison in happiness. So what the utility function does is it's a function, math, right, that simply maps each bundle to one measure, a number of utils. Okay? So 2 Lamborghinis and a what else is cool? Lamborghinis, I like Maseratis. Okay, 2 Lamborghinis and a Maserati give me 600 utils. 2 Fiat 500s and a Ford C-Max plug-in hybrid give me 0.2 utils, okay? So I prefer the first bundle to the second bundle. There's no way, the actual numbers I just gave you, a couple of you chuckled, right? But the numbers don't mean anything. All they reflect is a ranking, right? I prefer the first bundle to the second. What this is going to give me, this utility function, it's going to give rise to this indifference curve map that I showed you earlier. And we're going to have to do a little bit of work in order to get to that point. Let me drive home one more thing here. And this is this notion, you may have gotten this in other classes. If you've ever taken logic or anything like that, you know these terms. An ordinal measure is simply a ranking, right? The actual number itself doesn't mean anything. So if you race anything, right, finishing position in a race doesn't really tell you how fast you are, right? So if you finished first in the Pleasanton Livestock Annual Classic 5K, that doesn't necessarily mean you're incredibly fast. You're just, faster than the other people who participated here. However, if I'm telling you, I don't know, what's a fast mile? Somebody give me a number. 450 is a fast mile? Okay. So if you're running 430 miles, you're really fast, right? That's a cardinal measure. So time or speed over a certain distance is an actual cardinal measure where I can tell you how much faster you are than I am. Versus if we're telling you that you came in first in the race and I came 450th in the race, that doesn't really tell me how much faster you are than I am. So ordinal measures like utility are simply a ranking, and the value means absolutely nothing in absolute terms. Versus cardinal measures are absolute measures which allow you to rank, right? My 17-minute mile and your 450 mile, it means you are much, much faster than I am. I'm old and slow, right? But the point here is this finishing time is a cardinal measure. It lets me tell you that you're faster than I am, but it also lets me tell you how much faster you are than I am. Versus an ordinal measure will not let you make that ordinal, that absolute comparison. If we compared my monthly paycheck to your monthly paycheck, in 99.9% of the cases, I'm going to make more money than you are, right? If we actually compared numbers, because it's measured in dollars, we can come up with how much more money I do make every month than you're currently making, right? So income is a cardinal measure. Finishing position in a race and utility are ordinal measures. So if I asked you, how many utils are you getting out of this economics lecture? How many utils are you currently enjoying? 10. Right. I'm currently enjoying about 7,000 utils out of this economics lecture. But what's a util to you? What's a util to me? It's not comparable across individuals, right? You might actually be much happier right now than I am, right? You look like a very happy guy. So I think you're probably happier than I am. I'm an economist, German for crying out loud, right? So we can't compare utils across individuals. That's the first point here. And the numbers themselves are completely meaningless too, even within myself. If I'm telling you the utility I get out of giving this economics lecture is 7,000 utils, and me enjoying my salad from Mike Royales after this lunch is going to give me 20,000 utils, you can't say that the salad makes me roughly 3 times happier than the economics lecture. The only thing you're allowed to say is that the salad makes me happier than talking here for 80 minutes. So it only allows you a ranking. The actual number itself doesn't mean anything. And most importantly, it's not comparable across individuals, because you have your own scale, and utility just lets you rank bundles for yourself. Okay, here comes the performance piece. 6 minutes, I can do this. My wife's one of these... She does art that I can't explain, right? We've been together for like 21 years or something, and I still can't explain what she does. It's pretty interesting. And she has much cooler friends than I have. But there's a lot of like these performance artists out there, and I was finally in an art show recently, but I'll tell you about that when you're not paying to be here. What I'm going to show you is what I mean by a utility function, and I'm going to give you some examples, and next time I'm going to show you a computer simulation of it. But I think we're all on board that each bundle of goods gives me a level of happiness that I can assign to it. And then I can compare different bundles in terms of how much happiness they give to me, okay? So let's think about this for a second. What I'm going to do is I'm going to artificially create a 3D plot of different bundles, and I'm going to map it into utility, okay? So let's think of this here as the origin, okay? I'm standing at the 0, 0 point on some sort of plane. This wall right here is going to be my, what do we have, Reese's wall, right? Reese's, as I walk up this wall, and I'm right on, this wall is probably filthy, goodbye jacket. But the point here is as I walk along this wall, I'm increasing my number of Reese's, and I'm keeping my Hershey's constant, right? So if I go back to the origin, I can't slide along this wall, that's definitely impossible. But as I go in this direction here, this is going to be my, Hershey's direction. So as I walk along here, I'm increasing the number of Hershey's. If I walk anywhere in this space, I'm increasing Hershey's and Reese's at the same time, all right? So what I'm going to do is I'm going to meditate for a second here, and I'm going to record my state of happiness from having 0 Reese's and 0 Hershey's. 0 utils, okay? So I'm stuck right here in the corner, 0 utility. Now what I'm going to do is I'm going to add 1 Hershey's and 1 Reese's, okay? So I'm going to step out here. So 1 Hershey's, 1 Reese's, and I'm going to measure my level of utility. It was 0 before, but now I've got 1 each. So I'm going to measure it in 3-dimensional space. It's right here, 20 utils, okay? Now what I'm going to do is I'm going to, let me just add 1 Hershey's, okay? I'm going to walk over 1. I've now got 1 more Hershey's, 27 utils. Okay, I've got another point in my 3D space. Now what I'm going to do is I'm going to add 1 more Reese's, step out here, 35 utils, right? So what I could do is I could do this like run around here and at each point map out how many utils I get, and then map out that three-dimensional surface in terms of for each bundle, which tells me how many Reese's, how many Hershey's, how high off the ground I am, tells me what my utility level is. If I did that, and I'm telling you that because I know my own utility function, it starts at 0, and it looks something like this. It comes out of the wall, and then gets bigger and bigger and bigger, and looks like this sort of, if you cut a basketball in half and then into a quarter, and you sort of squished it down a little bit, it comes out of the wall like this. And I'll show you this in 3D in a second. So where else do we have these 3D type of settings? So I've got a mountain of utility now. Latitude is Reese's, longitude is Hershey's, and utility is altitude, right? So it's a mountain of utility. Where do we have this? Anybody follow these two guys in Yosemite? I mean, I didn't get anything done all break. I was just like on that thing that, you know, how he like jumped over and failed over and over again, and it was amazing. What mountain is this? Thank you. Good high school. All right, this is Mount Everest, all right? How do you figure out how to go up this mountain? Do you want to go up the steepest route first time you're going to go up? No. Well, maybe you are because you're a little bit, you know, you like the challenge. But generally speaking, what you're going to try and do is try and figure out a route up the mountain that's not so steep. What's a good way of doing that? Well, you build a model of Mount Everest based on satellite cartography, and then you take a little, you know, Lego man, and you walk him up the mountain and you figure out a route, right? Well, one way that you do it, and one way many of you actually go hiking, is you look at it from the top, right? That's Mount Everest from the top. And what do you have here in these lines? What are those? Topographical lines, right? They tell you how far away from sea level you are. If two lines are really far apart, that means you're rising 100 meters over a lot of horizontal distance, meaning it's a shallow incline. If the lines are really close together here, that means you're rising 100 meters over a very short distance. It's very steep. Now, what I'm telling you, and I'm going to show you next time, if I take my mountain of utility and I draw it like this, right? So this function that looks something like this that maps Reese's and Hershey's into utility, it builds a mountain. So if I look at the mountain from the top, this utility function from the top, and I draw these topographical lines, meaning lines where I'm equally happy, here I have lines where I'm equally far up off the ground, I get topographical lines in my utility function. These topographical lines are lines of bundles where I am equally happy or indifferent between the bundles. So what the utility function is going to get you, if you slice it at the same level of happiness, distance off the ground, is a bunch of topographical lines that ultimately tell you the same level of happiness or the set of bundles that you're indifferent between. So the topographical lines on a utility function are your indifference curves, and I will show you that next time. All right, I will see you on Thursday. Looking forward to it. If you want some chocolate, there's a bundle up here.